Picture this. Somewhere in the vast darkness of space, a dying star breathes its last breath. In a final, violent act, it unleashes a beam of pure destruction, a gamma-ray burst. This isn't just any explosion. In mere seconds, it releases more energy than our sun will produce in its entire 10 billion-year lifetime. A single gamma-ray burst can outshine entire galaxies, and if one were to strike Earth, the consequences would be unimaginable. But here's the million-dollar question. If the universe decided to fire one of these cosmic death rays in our direction, could humanity survive? To understand the threat, we first need to know what a gamma-ray burst actually is. These bursts, often called GRBs, are the most powerful explosions since the Big Bang. They come in two main flavors, long and short. The long ones, lasting anywhere from a few seconds to several minutes, are thought to be the death cries of massive stars collapsing into black holes. The short ones, which flash by in less than 2 seconds, are likely caused by the catastrophic collision to neutron stars, the incredibly dense remnants of dead suns. Both types are terrifying in their own right, but they share one thing in common. They fire their energy in narrow, focused beams, like a cosmic sniper rifle. Now, let's talk about what would happen if Earth found itself in the crosshairs of one of these beams. The first thing we'd notice, a blinding flash of gamma rays, light so energetic it makes X-rays look harmless. These rays would slant into our atmosphere, smashing apart molecules and triggering a chain reaction of destruction. The ozone layer, our planet's natural sunscreen, would be shredded in moments. Without it, the sun's ultraviolet radiation would pour down unchecked, scorching plant life, damaging DNA, and causing skin cancers to skyrocket. But the nightmare doesn't stop there. The gamma rays would also ionize the air, creating a toxic cocktail of nitrogen oxides. These chemicals would react with the remaining ozone, wiping out even more of our protective shield. Over time, this could lead to acid rain, further poisoning the environment. Some scientists believe a gamma-ray burst might have been responsible for one of Earth's worst mass extinctions, the Ordovician extinction, 440 million years ago, which wiped out nearly 85% of all marine species. If a GRB struck today, the results could be just as devastating, if not worse. Here's where things get really scary. The initial blast of gamma rays would be followed by a longer-lasting afterglow of X-rays and cosmic rays. These high-energy particles could fry satellites, disrupt power grids, and bathe the planet in dangerous radiation. Even underground shelters might not be enough to fully protect us. The combination of ozone loss, radiation sickness, and ecological collapse could push civilization to the brink. But before you start building a doomsday bunker, let's talk about the good news. The odds of this happening are astronomically low. GRBs are rare. We detect about 1 per day in the observable universe, but most come from billions of light-years away, far too distant to harm us. Even if one occurred in our own Milky Way galaxy, the beam would have to be pointed directly at Earth to cause damage. Given how vast space is, the chances of us being in the firing line are incredibly slim. Still, scientists take the threat seriously. NASA and other space agencies constantly monitor the skies for GRBs using satellites like the Fermi Gamma-Ray Space Telescope. If a dangerous burst were detected, we might have anywhere from minutes to hours of warning, not much, but enough to take emergency measures. Governments could issue radiation alerts, and people in the blast zone might have a slim chance to seek shelter. So, could humanity survive a gamma-ray burst? The answer is maybe. If the burst were close, within a few thousand light-years, it would likely be game over for most life on Earth. But if it were farther away, or if the beam only grazed us, some people might make it through. Underground habitats, shielded by thick layers of rock or water, could protect a lucky few. Stockpiled food, filtered air supplies, and radiation-resistant crops might keep survivors alive long enough to rebuild. The real challenge would be the aftermath. With the ozone layer gone, the sun's UV rays would make the surface deadly for years, possibly decades. Agriculture would collapse, leading to global famine. Ecosystems would unravel as species died off. The survivors would face a harsh, irradiated world, but humans are nothing if not adaptable. We've endured ice ages, supervolcanoes, and pandemics. If anyone could claw their way back from the brink, it's us. In the end, gamma-ray bursts are a reminder of just how fragile our existence is in this vast, unpredictable universe. They're also a testament to how lucky we are, lucky that GRBs are rare, lucky that space is so big, And lucky that, for now at least, the cosmos seems content to leave us alone. But as we look to the stars and dream of exploring the galaxy, we should also remember, the universe is a beautiful, but dangerous place. And if we ever do face a gamma ray burst, our best hope lies in science, preparation, and the unshakable will to survive. So the next time you gaze up at the night sky, take a moment to appreciate just how peaceful it seems. Because out there, hidden in the darkness, are forces beyond our comprehension, forces that could wipe us out in an instant. But for now, we're safe. And as long as we keep learning, keep exploring, and keep pushing the boundaries of what's possible, we just might stand a chance against whatever the universe throws at us.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.